Okay, we're going to take a look at scientific notation. It's a way of measurement. And when we're looking at measurements, it's a quantitative observation. That means quantitative, quantity. We can put a number to it. So it is a numerical observation. It has two parts. There's a number and there's a unit. Both of them are necessary. Both of them describe the quantity that you're talking about. Number tells the comparison, unit tells the scale. For instance, 1 centimeter and 1 millimeter. The number's the same, okay, but the unit is different, and therefore the quantity that we're talking about is different. Okay, so scientific notation is something that we're going to be using particularly when we're talking about particles and a mole. Scientific notation is used to express very large or very small numbers so that we don't have to write all those zeros. And it expresses a number as a product of a number between 1 and 10 and the appropriate power of 10. So if we look at an example, 93 million is 9.3 times 10 million. Well, the number part is 9.3. This is a number between 1 and 10. Notice there's one digit to the left of this decimal point. And then the appropriate number of 10. What does 10 to the 7th represent? Well, it represents 10 million. So it's just a different way of representing this number with all those zeros. We'll find that in chemistry, we often deal with a number that is 6.022 times 10 to the 23rd. Okay, 23rd. That's a lot of zeros. All right, we don't want to write them, so we want to make sure that we can write numbers in scientific notation and that we can do calculations with numbers in scientific notation. Okay, so using scientific notation, we can write any number as the product of a 1 and a power of 10. Okay, either positive or negative, and I should have said a number between 1 and 10 and a power of 10. So I can put any number into scientific notation. The power of 10 depends on the number of places the decimal point is moved and in which direction. The number of places the decimal point is moved determines the power of 10. The direction determines whether that power is positive or negative. If the decimal point is moved to the left, then the power of 10 is positive, and that's what I'm converting to scientific notation. Okay. So for instance, 345, I'm moving the decimal place from here to here. Okay, so it's a positive, and I've moved it 2 places, so the power is 2. If I move that decimal place going from a standard form number to a scientific notation, I'm going to be moving this 2, so the number is 2, but I've moved it to the right, so it's a negative 2. Okay. I sometimes had trouble remembering whether it was a positive or whether it was a negative. Remember that 10 squared is 100. So anything that has a positive exponent is going to be a number greater than 1. Remember, 10 to the negative 2 is really 1 over 10 squared, which is 1 over 100, which is 0.01. So anything with a negative exponent on that 10 is going to be a number less than 1, okay, a fractional number. That helps me remember, all right? So whether you're going from scientific notation to standard form or standard form to scientific notation, okay, that 10 to the 2 is going to mean a larger number. 10 to a negative is going to mean a smaller than 1 number. So let's put our newfound knowledge to work. Which of the following correctly expresses 7,882 in scientific notation? right? Well, if I have 7,882, I'm going to be moving the decimal point 1 to 3 places because I want one number to the left of the decimal. I've moved it 3 places. This number 7,882 is greater than 1, so it's a positive 3. So the answer, hopefully, will be C. Yay, we're very good. Now let's look at this next number. Okay, so I want to change 0.12340 to scientific notation. I'm going to move that 0, 1, 2, 3, 4, 5 places. 4.96 times 10 to the 1, 2, 3, 4, 5 places. This number is less than 1, so it will be a negative 5. So I say the answer is A. Yay! It agrees. Okay, so that was a review of scientific notation. Okay, let's talk about nature of measurement and different units. Okay, again, that measurement is a quantitative observation, meaning it has a number to it, and it consists of 2 parts. Number and a scale, a unit. All right, we've been using these for a while. All right, what kind of units do you need to know? You need to know that mass is measured in grams or kilograms. The standard unit is actually kilogram, all right, but that has a prefix kilo on it. Length you need to know is meters. Its symbol is M. You need to know that the temperature of something is a Kelvin, K. We can also use degrees Celsius. And you do need to know that the amount of a substance is a mole, and we'll be talking about that in this unit. Those are the 4 physical quantities, name of the unit, and the abbreviations that you need to know. And again, kilogram is listed as kilogram. We'll typically use grams. The kilo is just because that's related to the standard that's housed in the International Metric System Standards place. Prefixes used in the SI system. Prefixes are used to change the size of a unit. Which ones do you need to know? Well, it is assumed that you know kilo, that kilo means 1,000. So that means 1 kilogram is equal to 1,000 grams. It is expected that you know that. Centi, represented by a C, centi actually means 0.01. What this means is there are 100 centimeters in 1 meter. If you notice this kilo, even though the kilo is here, it's 1 kilo is 1,000. Centi, 100 centimeters in a meter. You need to know milli. Milli, 1,000 milliliters in 1 liter. If you know those 3, you're doing pretty good. All right, those are the 3 that are expected we can use in class, and you know them. All right. Length, it's the meter. Know the meter. Volume, okay, is a measure of the 3D space. Okay. This is important for you to know. 1 centimeter cubed is equal to 1 milliliter. 1 centimeter cubed is equal to 1 milliliter. Volume, SI unit is actually a cubic meter. Commonly we measure it in centimeters cubed. 1 milliliter is 1 centimeter cubed. 1 liter is 1 decimeter cubed. We won't use that a whole lot. Mass. Mass is measured, it's defined as the amount of matter present in an object. You should know this definition. The SI unit again is a kilogram. I always remember this conversion, 454 grams in 1 pound. You don't need to memorize that, it's just useful. So concept checked. Let's ask a question. What statement below contain improper uses of commonly used units? Meaning what doesn't make sense? A gallon of milk is equal to 4 liters of milk. A 200-pound man has a mass of about 90 kilograms. Basketball player has a height of 7 meters, and a nickel is 6.5 centimeters thick. Well, a liter, 1 liter, is about equal to 1 quart. There's 4 quarts in a gallon, so this one makes sense. 200-pound man is about 90 kilograms. Well, 90 kilograms, in 1 kilogram there's 1,000 grams, and in 454 grams there's 1 pound. Alright, that's about half. Well, this would be about that, right? And then that would equal about 180 pounds. Oh no, that's about right. Okay. 7 meters. Well, if you think about a meter stick is roughly equivalent to a yardstick. A yardstick has 3 feet in it. So this is really saying that it's about 21 foot. That doesn't seem right. 6.5 centimeters. A centimeter is about that. A nickel is, no, that's just silly. All right, let's see if you're right. That's good. Ah, very good.